Our Earth has an inner sun. That sun radiates energy released by radioactive minerals created by a supernova, now more than 5 billion years gone. The energy released by Earth's core is essential to all life on the planet. Early volcanic vents created rudimentary sugars feeding primitive organisms which went on to become all living things. Our Earth's oceans and atmosphere were secreted from an Earth warmed by two suns, one inner and one outer. Earth's inner sun generates a weak but effective magnetic field protecting all Earth's living things from death-dealing blows from our outer sun. Convective cells circulating through Earth's mantle constantly drive the process of continental migration. The last time all the continents were together was some 200 million years ago, a coalescence that started some 100 million years earlier.
By this, our sixth Zenoic halving of time, 215 million years ago, the continents were preparing to drift apart once again. This was the Triassic period, the earliest era of the dinosaurs. A great die-off of older dinosaur forms, the Archosaurs, would occur as Pangaea dispersed. The surviving dinosaurs of the later Jurassic and Cretaceous eras would go on to dominate the world for some 140 million years.
As a supercontinent, Pangaea was largely arid and sparsely vegetated. While true plants, rather than simple algae and fungi, may have evolved as early as the Tonian era, 900 million years ago, and diversified in the late Silurian, 420 million years ago, they didn't move inland until the Carboniferous Period, 360 million years ago. These first seed-bearing plants had appeared long before Pangaea came together. Plants, of course, are essential as a food source for animals, which must directly or indirectly consume the carbohydrates, fats, and proteins plants organically synthesize from soil, sunlight, and water. The first animals to move inland with seed and spore-bearing plants were insects. Due to high oxygen levels released by plants and lack of predation, many insects were mega-sized, some 10 to 20 times larger than today. Insects evolved with the plants, moving inland with them during the Carboniferous. Unlike plants, insects fully evolved within their first 100 million years. As a result, most, but not all, of today's insects were around when Pangaea was still a supercontinent. But by the end of the Carboniferous, insects no longer dominated the land.
By the time insects matured as an order, rhinoceros-sized archosaurs populated Pangaea. The dinosaurs of the past, as well as today's birds and reptiles, all evolved from this group of slow-moving creatures. Such creatures were held up by short, thick, widespread legs guided by brains similar to modern reptiles, brainstem, bud, and cerebellum. These ancient dinosaurs moved slowly from one watering hole to the next, grazing on the sparse vegetation of a largely arid land. Of course, these lumbering herbivores were prey to equally large, but far less numerous, slow-moving carnivores whose teeth and digestive systems had not evolved to eat the plants of the time. Today, archosaurs take the form of alligators and crocodiles, but in aquatic rather than terrestrial form. By 215 million years ago, the earliest predecessors of mammals, egg-laying monotremes, burrowed into sandy ground by day and nibbled on nearby vegetation by night. Such nocturnal proto-mammals necessarily developed internally generated body heat and improved visual acuity for cool, low-light nocturnal conditions. By this time, too, the earliest, small but sprightly dinosaurs with more efficient kidneys for improved water retention and more evolved brains had begun evolutionary ascent. Such small dinosaurs were warm-blooded, supporting higher metabolic rates. Meanwhile, their intelligence made them capable of more than simple grazing and ambush predation as a way of life. This was the age of eggs. Fish in water had sacs, while creatures on land, shells. Eggs had to be fertilized. Eggs had to be hidden. Eggs had to be protected. Eggs had to be kept warm, but eggs were very much on the menu. Species able to hatch those eggs and raise hatchlings successfully persisted. Those that did not fell by the wayside, leaving behind stony fossils instead of evolving offspring.
The floating of continents on Earth's viscous mantle led to the breakup of Pangaea. With its splintering, the massive Triassic-Jurassic extinction occurred, involving 3/4 of all species. With that breakup, winds and clouds carried rainfall across geographically smaller, but far more vital, continents and subcontinents. The Jurassic, harboring the largest herbivores land had ever supported, gave way to the Cretaceous.
By our seventh halving, 110 million years ago, flowering plants freely populated the open spaces left behind by huge 130-foot-long herbisaurs that had earlier trampled their way through the thick, piney forest of the preceding Jurassic. By this time, herbivores were smaller, but quicker on their feet. Increased socialization made it possible for them to better defend themselves against predators who themselves would gain in size and cunning until a 10-kilometer size comet or asteroid struck the Yucatan Peninsula some 45 million years later. The Cretaceous was a noisy place. Social behavior, encouraged by species-specific calls among creatures, was endemic. Although true placental mammals were rare, marsupials birthed young within protected birth sacs and nursed undeveloped embryos on teats. For marsupials, the egg no longer needed a protective shell. Birds, also well represented in the Cretaceous, did not develop this trick. Instead, they retreated to the trees, building nests and using all that extra body heat to mature embryos quickly. This allowed the birds to displace the often larger flying reptiles, pterosaurs. Ultimately, the birds would carry forward the dinosaur legacy, although in much diminished form. By the time of the Cretaceous, the simple Archosaurian brain had sprouted 2 lateral hemispheres, the diencephalon. This allowed the dinosaurs and birds greater freedom of individual behavior. Meanwhile, the first true placental mammals were about to appear. Such mammals sported a limbic system, the emotive brain, reinforcing emotional bonds between parents and siblings while also supporting the ability to play. Fertile soil in which imagination would later take root. As in the earlier Triassic and Jurassic periods, the Cretaceous was a time in which large creatures were always on the move. The high rate at which plant life was consumed made moving on a necessity. Dung left behind by these creatures, along with new species of pollinating insects, such as bees, would accelerate the pace at which flowering plants brought color and beauty to the open spaces.
But the dinosaurs of the Triassic, Jurassic, and even the Cretaceous were not equipped to appreciate such beauty. Lacking in emotive development, their lives were dominated by the drumbeat of survive, eat, survive, grow, survive, reproduce, survive. But out there, beyond the bounds of Earth, a small chunk of leftover protoplanetary material was also moving on, looking to become part of something greater than itself. After a major disaster such as the Cretaceous-Paleogene CP boundary impact event, it takes about 10 million years for Earth's fauna to recover and flourish. Though individual dinosaurs survived for a time, the dinosaurs as an order of living things died off rapidly. Their large, now much too cold, unroosted eggs failed to pass the test of the great chill kill-off that followed. By 55 million years ago, during the Paleocene epoch, Earth's continents were undergoing shifts that would lead to their current configurations. Iceland was separating from Europe. Africa and India had yet to crash into Eurasia. South America would remain long distinct from North. Flowering plants were widespread. placental mammals had fully emerged, allowing them to nurture young and utero well past the embryonic stage of development.